the recorder. Okay, cool. So, all right, our task for this evening is to create a schema for a restaurant. So, what sorts of things might be involved when creating a database for a restaurant?
The orders, like keeping track of orders.
Okay, yeah, we should probably keep track of orders, right? So, have to create like a table or orders. Okay. What else?
New items.
Okay, yeah. So we'll say like menu items or menu items. Yeah. Uh,
Customers.
customers. Yep. And let's see.
Prices.
Yeah, sure. We can add prices. And so it looks like some of you guys might have already looked at the curriculum for today, which well, that makes things a little bit easier. Okay, so we've got our four categories for our tables. And here, I'll just make all of these like singular just to keep it easier. So uh let's start with the simplest one. Let's start with so what I like to do when designing a database is start by just writing down all of the different things that could be associated with each table and do the relationships after that. So let's start with the menu items. So what are things that we're going to need for menu items?
The name.
Okay, name. And then what uh what type of variable is that?
Varchar, I think
Okay.
or text, one of them.
Yeah, sure. Let's make it a varchar and give it like 40 characters. All right. What else?
Maybe like a unique ID to identify each item and use it for relating the tables, I guess.
Okay, yep. So in every single table, we want to have a unique ID. So we could just call it like menu item ID. And what type of variable is our ID?
Serial key.
Perfect. Or we can call it a serial key. You can also call it like a primary key, and that's an integer. The nice thing I like about quick database diagrams is when you label something as a primary key in their shorthand notation, it highlights it in blue and puts a little key next to it, which I think is really helpful, especially if you forget what your primary key is. Okay, so we've got the menu item, we've got the ID, we've got the name. I guess we could add in like a description. Um, Now, let me ask this. Do all items necessarily have a name? It's not a trick question.
I would say they should have a name. Yeah. If they're on the
Okay.
menu.
Yeah, if it's on the menu, it should have a name, right? Like you don't want to say, can I have the food that's made with eggs, flour, and milk? That just sounds really bad. Yeah, everything on a menu should have a name. But does everything on a menu necessarily have a description?
Probably not.
Yeah, probably not, right? Like, I mean, if Coca-Cola is on the menu, there's probably not going to be a description of Coca-Cola. So let's say that our menu items do have descriptions. How can I specify that the description field might be blank?
Make it nullable.
Nullable, exactly. How do I do that?
Type null.
Yep, just type null. That's it. So null, and then we'll just make it text. So if you take a look now at at menu item, we see that it has a little question mark there. And the question mark is because we added this null descriptor. So if I take that out, it says here that it's text full, like without the question mark. What that means is every single time you put in a menu item, it has to have a description. Now, if we say that the menu item is nullable, then it's like, okay, it might be text or it might not be anything and it'll be blank. So I think that's probably, oh, well, I guess there is one more thing we should probably do for our menu item.
Price.
Yeah, price or maybe let's change price to category. Because, like, for example, I feel like it's a little bit strange to have individual prices, in my opinion, be a separate class. But let's say like all of the like soft drinks cost $5. Then you could have a category that's soft drinks, and then you automatically know the price or something like that. So let's add in a category here. Category. So real quick, I'm also just going to add in a category ID because, well, why would I add in a category ID?
I would imagine to easily kind of differentiate between, say, salads or sandwiches, pasta.
So we can use the category ID to differentiate between the different categories. Nice and simple. Then how can I link this category? Or number one, in menu item, if I'm trying to use this category to reference a category up here, how do I do that in SQL? Let's see, Sandy. Just like in general, how do you link to, if I want to link a menu item to a category, what do I have to do?
You would say references, the table, and in parentheses, the field.
Yep, perfect. Or like more general, the really easy way we can do this is we can take an arrow and drag it over. That's the nice thing about quick database diagrams. You don't have to write everything out. But it does give you some nice little notation. So let's break down what it says over here. So I have a variable in menu item called category ID. And it now says that it's not a primary key. It's just a regular functional key that references, and this is a directional arrow. So category ID references category ID in the table category. So, all right, let's add in a couple other things. So we'll just do the same thing for a category. We'll give it a name, and then we can give it a price, let's say. So how can I give it a price? What sort of classes can I use for that?
Money?
Yeah, we can use money. So the nice thing about SQL is if you're entering, well, a monetary amount, there is a money field, which is nice. And we could also say not null. Oh, well. Well, they're in at least, okay, the database diagram doesn't like doing that, but in SQL like itself, you can specify that a field cannot be null. All right, so we've got those two down. So we have our category, we have our menu item. So let's go to order. So let me ask you guys, so what things go in an order, like in general?
An order number.
Okay.
The price, probably.
Okay.
That's all I got.
Okay. That's all right. Who have I not heard from yet?
Maybe menu item quantities.
Okay, yeah, we can do menu item, quantity, and there's one thing that we're missing.
You need a customer ID so we know who ordered it.
Bingo. Okay. So let's also just set up customer real quick. So say customer ID, we'll have name, we can have address. That's good enough. Okay. So there's a little bit of a problem with the way that we're setting this up. So before I say what it is, I want to see if we can all figure it out collectively. So in order, right now we can have each row is going to be a singular order. Now, when you guys order food from a restaurant, do you usually order like only one item, or do you generally order multiple items, like in the same order?
Multiple.
Multiple, right. So if you're ordering now, based on the setup that we have here, for a single order ID, can we order one thing or can we order multiple things? Disregarding the quantity then.
Be one thing.
Yeah, one thing. And why is that? So have you guys have talked about the different types of relationships before, right? Like one-to-one and many-to-one and stuff like that.
Yes.
Okay, perfect. So, let's see. So Charles, based on what we've just talked about, is between orders and menu items, should there be a one-to-one relationship, one to many, many to one, many to many, and why?
So I would say at least a one to many because you could have many items for an order. But I think it could also be many to many because it might be the case you have multiple orders that have the same item in them because the items are just that item. So I think it probably will wind up being a many to many at the end of the day.
Yeah, that sounds reasonable. What do the rest of y'all think? Do you agree with Charles that it'll probably be a many to many? Or anyone want to make a case against it?
I think many to many makes sense.
Yeah, all right. So let's see. So Matt, since you did say something, Matt, why don't you tell me how we can create a many to many relationship between orders and menu items?
I'm not sure how you would do that. I've only ever done one to many.
We actually didn't cover the how to do the many to many or many to one relationships, just one to one.
Okay. Okay, that is good to know. So, all right,
Create a
let's
separate table.
Yeah, a separate table is going to be the easiest way to do it. So Jordan, do you want to elaborate a little bit more on that? Like
Yeah, so
just ideas.
So I'd create a separate table. And I name it something. I don't even know what to name it. Order items. I don't know. And then I would pass in the order ID and the menu item ID as foreign keys. And then have them be one to many relationships to it.
Yeah, exactly. So here, let's just make this a primary key and an integer. So this guy will go here, and whoop, that is not. Okay, that's weird. Yeah, so no, okay. So order ID gets linked to this, and menu item ID gets linked to that. So what? And then, we did forget one thing. We always, in every single table, you need to have a primary key. So we could say like order item ID, and then this is going to be a primary key and an integer. Okay, so Jordan, thank you for that explanation. That was perfect. So let's talk through what Jordan just did. So let me switch over to my VS Code because this is how I like to diagram things. And let me just make like a blank txt file. So what exactly did we just do? Well, we have three tables. We've got orders, order items, and menu items. So we have our order table, and okay, let's rename this from blank. Let's call this orders. Then we'll just make a new one called like items. And then this will be like order items. And let me split screen these a little bit. Okay, so let's say that, so what were the things that we had for an individual order? You had the ID, the price. So let's just do like ID is gonna, let's say that the first one is just like ID 1, and you are ordering, let's say, item 1, and actually this is not a great way of doing it. Here, let me open Microsoft Paint. That's probably a little bit easier. Okay, can you guys all see MS Paint now?
Yes.
Okay, cool. So here, let's say that we have our orders as this thing on the left. Orders. And we also have our menu items on the right. So menu, nope. Okay. Menu items. So let's say in order number 1, you are going to be ordering, let's say 1, like you're ordering like a bunch of different things. Like you're ordering like 3 different random dishes in a singular order. But at the same time, one person or like 10 different people could order the same dish, and each of those would be in a different order. So the reason why it's many to many is because one order can have many dishes, and one menu item can be in many orders. Now, the only problem is in SQL, like in native default regular SQL, we can't implement this sort of web without adding additional tables. Because the way that SQL lets you refer to things is either something is going to be a primary key, which is going to be like your 1, 2, 3, 4, 5, ... Or it's going to be a foreign key. And a foreign key can only reference one thing at a time. So default SQL is always going to be 1-to-1 relationships like this. And that is where adding in those tables comes in handy. So this is kind of like a join table, or like, that's how I sometimes like to think of it. It's basically a table that connects whatever things you're working. So let me change this. And let's say that this is going to be order items. So let's say I'll just give a bunch of orders. We'll make it like 5 orders with 5 menu items. Okay, so, and then let's say, let's just make like the primary key here, 1, 2, 3, 4, and 5. So let's say in order number 1, that I am ordering, or let's say that like I would like to order menu items number 2 and number 4. So let's just break down order items real quick so you guys can see what this looks like. So we have the primary key is going to be the first thing on the left. Then after that, you're going to have like the order ID. And after the order ID, we'll have the menu item ID. So let's say that in order 1 is supposed to have 3 different menu items. So in that case, let's say order 1, you're ordering items 3, 4, and 5. So first we have the primary key, which we don't care about. Then we have order ID number 1. I'll change that to black so it matches. And the menu items, well, again, we can only put 1 menu item for each order item. So let's start with menu item 1. But remember that we just said order 1 has menu item 2 associated with it and menu item 3. So what we can do is we can say 1 goes up with the first one, then item 2 goes with the second order item, and then, oh, wait, let me change the color real quick just to make it more obvious. 1, 2, 3. And these are all going to be red. But the order ID does not change. So essentially, what this middle table lets us do with order items is it lets us essentially say, hey, I have a single order ID, but this order ID is linked to all 3 of these menu items. And vice versa. Each of those menu items is linked to whatever order IDs are listed. So what this table lets us do, essentially, is like before, where I was saying how we can't draw like multiple arrows going to, say, from one order to each of the menu items. What this setup lets us do is it lets us draw an individual arrow to, let's say, from an order to an order ID, then to a menu ID, and then over here. And then we can do the exact same thing, but going from the order, linking the order IDs to the menu IDs. So essentially, it's a little bit convoluted, but in order to create the many-to-many, or right now it looks like a one-to-many, but it is a many-to-many relationship, you're basically sort of linking the orders to the menus using this middle table. So does the rationale behind why this middle table needs to exist make sense? Are there any questions about that? Again, I know it is really weird. So if you guys do have questions, like please ask, because this is something that is going to come up like over and over and over again.
I guess it's mostly clear. The one question I have, each order in this case is referencing over. So each order ID, is it's going to, so all 3 of those are going to be different primary key under the order items, essentially, right? So we have 3 items that are going to order number 1, and that would then be referencing the 3 primary keys under order items, right? Those would be those 3 items.
Yes,
Okay.
basically, yeah.
Okay.
All right, so the 3 items would be the primary keys of the menu items.
Got it. Thank you.
Yep. So the only reason like order items has a primary key is because SQL basically mandates you to have one. Otherwise, we don't like actually care about the primary key for order items. It doesn't matter for us. Any other questions? Is this roughly making sense to everyone? Okay, fantastic. So let me find my way back to code database diagrams. Okay, so we also just like shuffle things around a little bit in here to make it a little bit easier to read. So right now we have our order, which has, and we have a customer too. We should probably link the customer. So we have a customer who is going to make an order. Here, let's move this down here, let's say. So the customer makes an order. Now we don't need let's see, we could do a price as like total price. Don't need either of those. That's a little better. Okay, so we have a customer who has their ID, a name, and address. The customer can make an order, and an order has an ID and a total price. So each order has an order ID. And let's forget about the join table for now. On the other side, we have menu items. Each menu item has a ID, a name, because you can only really order something if it has a name. It has a description, and it has a category ID. And the category is something like salad or pizza or whatnot. And we'll assume that each category has the same price. So like all pizzas cost $5 or something, which would be amazing. The way that we link the orders to the menu items, because again, it's a many to many field, is by using this join table in the middle. So in this way, we can have, let's say, one specific order ID can be linked to multiple menu items and vice versa. So this is basically going to be our overall schema for this database. Does the overall idea that we have make sense? Are there any questions that anyone has that they'd like to mention?
Do you have any advice regarding instances where a field within a table might be better off being its own table? So for instance, the price, because on first glance, I would have included price within maybe menu item rather than have it be like its own separate table.
Honestly, that's probably a very good idea, and I think so that's within like yeah, let's just move that. That's a good idea. Honestly, a lot of it just comes down to, I would say some of it just comes down to common sense, and then also just like good design decisions. So do you necessarily want to have a table that's just a list of numbers and prices? Maybe not. Okay, so where does the price usually come into it? Does a customer have a price? No, that just sounds wrong. Does an order have a price? Yes, but that's like calculated. Does a menu item have a price? Yeah, because I can pay $5 for a glass of lemonade, or like $20 for a sandwich or something like that. Very, very hyperinflated amounts, but still. So what I really like to do when designing databases is just run through like in your head or on paper. Okay, what are the things that need to go in each of these tables? And then how are these things connected to each other? That's at least what I would recommend.
Thank you.
Mm-hmm. I don't have it on me right now, but I'll try to find it. I have a slide deck that talks about the difference between one-to-one, one-to-many, and many-to-many relationships, and I'll send that to you guys in the Slack if I'm able to dig that up once we wrap up. Okay, so any other questions about the schema, anything that we've drawn before we move to actually writing out our SQL code for this database? Okay, so if you want to screenshot this or something, feel free to. I'm just gonna copy paste into VS Code once I find the window. Perfect. Okay, and let me just delete like half of these. Delete that. And all right, so this is the schema that we came up with in our database diagram drawer thing. So let's write out these tables in SQL. So I want to write a init.sql file, just like the ones that we've been using over the past week. So let's see. Matt H, what is the first thing we should do in a init.sql file when we do not have a database, we don't have any tables, we literally are starting with nothing, and we need to create a whole database? What's the first thing we should do?
You need to create the database.
Yep.
It'll just say create database.
Okay, yeah, so we can say create database.
Whatever you want to call it.
Okay, so let's say create, I'll write it in all caps, database, restaurant 1. Okay. What do we do
You
next?
need to connect to it.
So we'll do connect restaurant 1. Or I guess we don't really need the semicolon. All right. Let's see. Eden, how can I create the order table, the top one?
You can create a table by, hold on. I mean, you can add information, but you need to create the table first.
Yep.
Isn't it like create table, and then you can put order, and then since this is order ID and customer ID, you can I mean, you can add the variables, but I'm trying to figure out how to add it. So let me see. So this is the primary key. So order ID and then serial primary key.
Yep, perfect. Serial and then primary key.
And then for customer ID, you can, so this is a foreign key. I'm not sure as far as foreign key. I would probably say the same as primary key, but I can't be sure. Oh, wait, hold on. So we're connecting this to something else.
Yeah, so we're connecting this to the customer database, which hasn't been made yet, but it will.
Yeah. So maybe null?
We could do null. Does anyone remember how to connect one table to another?
Use references.
References, yep. So we're going to say that customer ID is an integer that references And then just went to reference customer ID. And then we can also just create like a customer table real quick. Nope, I want to copy this. Say customer, and then customer ID, and then we can just say name, and then varchar 40. Let's see. But yeah, so nice work, Eden. Thank you for helping us create those tables. All right, now I've got a question for the class. What on earth is name doing being blue?
It's a keyword for a SQL.
Yep, exactly. So it's a keyword, it's a protected word, right? Just like for or if or something like that. So let's change it from name to customer name. Yeah, that should work. And we'll forget about the address and stuff. So real quick, let's go ahead and create the other tables. So let's do create table menu item, and we'll just run through the exact same thing. All right, so we're going to have a menu item ID, which is going to be a serial primary key. We'll have a, let's say, item name, which is going to be a varchar 40. We can have description. Oh, that looks like it's also protected. Let's say item description, and then we'll just say null text. And then we have to do the same thing that we did for order with the references. So instead of customer ID, this now turns into category ID. Or honestly, we can just forget about the category for now. Because I think, does the idea make sense for everyone for how we do this, like the referencing from the order to the customer ID or the menu item to the category? Okay, cool. So we'll just leave that out just so that we don't have to add a bajillion tables. Under order, customer, menu item. Now we just need a way to connect the orders to the menu items. And that's where this order item class comes in. So we'll create table, order item. So the first thing we're going to have is order item ID, which is our serial primary key. Then we have the order ID. And then we have the menu item ID. So this is also, we're going to write these the exact same way that we wrote customer ID up here. So the order ID is going to be an int references order ID. And menu item is going to be an int that references menu item ID. And honestly, that's about it for our database.
Do you need to move customer up to the top since the order table references customer?
That's probably a good idea. Yeah, let's do that real quick. But yeah, so now customer is at the top, and then everything that depends on it is down at the bottom. But yeah, I mean, that's actually about it. So that's the first database created. Let me go ahead and switch over to GitHub real quick. So in the example that was on GitHub, they basically run through the exact same thing that we did. So they have something called a rest order. They have the rest order, and then order dishes, and then dish. So they called that little linking table order dishes. But again, basically the exact same thing. So also let's just talk through relationships between these real quick. So in this case, one customer can have many rest orders. And think about why that is. I can have my customer ID can be linked to a rest order with ID 1. It can be linked to a rest order whose ID is 15, or some other thing. It can be linked to as many rest orders as possible. However, an individual rest order is only linked to one customer. So just to rephrase, a customer can be linked to many orders, right? And that makes sense because I can order the same like things from a restaurant like 15 times. But the rest order is only linked to one customer. Like one person makes an order. You don't have 15 people making the same order in an ideal world. So then we have rest order and dish. It's a many-to-many relationship. And that's what we did with this order dishes. And then dish is connected to price. And that's about it. So there's SQL implementation, all very, very similar to what we just did, right? So you have the customer up top, then the rest order down here. And remember that the ID is what's referencing the customer ID. Again, basically the same thing that we just did. And they do have a example repository called Restaurant BB that you guys are welcome to use. They have a bunch of dummy data in it, which is great. If you want to look at their init.sql file, so they do exactly what we did. So create the database, connect the database, they create a bunch of tables, and then they just add in a bunch of mock data. So if you guys would like to play around with that and do some queries, you're welcome to. Otherwise, we'll move on to today's challenge. Do you guys have any questions, comments, concerns, anything like that?